Hello, everyone, and welcome to our ASK Online Academy. It's 1 minute to go, but I think we can start. Today's webinar is about improved casting quality and optimized environmental footprint with modular feeding system. My name is Isabel Dickmann, and I will moderate today's webinar and guide you through the webinar and also take care of all your questions at the end. The speaker for today's webinar is Stefan Fischer. He's an expert from ASK Chemicals for the feeding systems, and he will present to you the webinar. Before we can start with the presentation, though, we have some things we need to be aware of. We have to organize the notes for you. Because of data protection reasons, we are not able to view or see clear names. The image and the camera is also deactivated. You can submit your questions via the chat function on your right-hand side. The Q&A mode is active. Of course, if you are here with your mobile phone or your mobile device, the chat is accessible through the green arrow. We will try to answer all questions at the end of the webinar, and hopefully we can answer all of them. If we don't have time, of course, we will answer every question personally, and we will get back to you. We will record this webinar, and we will send it to you afterwards to all the participants. Of course, if you want to share it, there will be an on-demand version available. And now I hand over to my colleague, dear Stefan. You can start.
Thank you very much, Isabel, for your kind introduction. A warm welcome also from my side to our today's webinar. I'd like to tell you something about the basics of feeding, the technology about exothermic feeding systems, and to give you a product portfolio overview. So let's start with the basics. Basics is what we face all time in Foundry is the shrinkage. So the shrinkage, we have three different types of shrinkage. We have the solid shrinkage, what is compensated by the pattern maker already. We have also the liquid shrinkage, what happens on temperatures which are upper the liquidus temperature. And we have also the solidification shrinkage, what happens between the liquidus temperature and the solidus temperature. If we do not do anything against this shrinkage, we will face some shrinkage defects, let's say holes in the casting, what we do not want. To get a better image about this calculation and so on, the Foundryman have developed the modulus calculation. The modulus of the casting or of sections of the casting is calculated by volume divided by the cooling surface. In this case, the volume stands for the heat content of the section or of the casting, and the surface stands for the heat lead off of the section or casting. So that means even if we calculate geometrical values and we have, in this case, a length as results, this length does not really stand for the geometric length. This stands for the time of solidification of castings. This is an important point. And today, this module calculation is mostly done with simulation programs. In the past, it was much more complicated to define the right sections and to calculate it on the right way. It was more or less only an approach, but with this modern simulation programs, it's possible to get much more correct results on this. So this was, of course, is available for this calculation. You need for the calculation also of the risers. And in the risers, we have let's say, three different types of risers. We have the natural risers, we have the exothermic risers, and we have also in between both of them the insulating risers, which are used in the foundry praxis. So I'd like to tell you something about the technology of the exothermic risers today. The basics for these exothermic risers is the Goldschmidt method, also called thermate reaction. This is where aluminium and iron oxide reacts together, and this reaction reaches temperatures up to 2400 degrees, which are not needed in the foundry applications. That's why we steer this reaction with our oxygen-bearing additives and also with the filling compounds, what we have here inside. To start this reaction, we also need a fluorine carrier, a cryolite, or magnesium, and of course, to give fixed geometry with the needed strengths, we need binders to create these exothermic risers. In these binders, we have also two different types. We have the inorganic binders, which is a sodium silicate. These risers mostly are based on sand as filling compounds. And we have also the organic binders, which are based mostly on microspheres. For these organic binders, you can use cold box phenolic binders or other resins can use as a binder here. So what is the difference between the difference in fabrication of risers with these different types? So you have a solid mixture of the exothermic powder and the filling compounds. In both cases, you have the sodium silicate binder in the case of inorganic risers, and in this case, in our production, we use polyurethane cold box binder. You have the shooting machine, which cures the riser then, or the mixture, the formulation then with carbon dioxide, or the shooting machine in the organic riser production cures the riser with amine. The big difference is the oven, because the CO2 allows only pre-curing. So the final curing is done then in a drying oven, and after the drying oven, the riser has his final strength. After this, the accessories which are needed for the riser, like for example breaker cores, metal tubes, or things like this, are implemented. And after this, the risers go to the packaging. One important thing is the exothermic curve, what we have to achieve with our risers. And these are the modulus influencing factors, which are also tested in the quality control on a sample specimen to have a comparability also for the different riser sizes with the same formulation. Important point here is the ignition time, so the time which is needed to ignite the exothermic reaction. Important is also the burning time, the maximum temperature, and the holding temperature over 1140 degrees Celsius. This is very important to have different formulations, because a small riser needs a much faster ignition time, but the time holding over temperatures over 1140 degrees is not so long as this, what we have heard before, is depending on the solidification time and the modulus. Risers with a higher modulus, let's say bigger risers, have to hold this temperature over a much longer time. But in this case, the ignition time, for example, is less important and can be a little bit slower. So which are the advantages of the different formulations? Let's start with the water class formulation. We have here a completely carbon-free formulation of the ExoMass, and therefore there is no carbon entry into the molding sand. The riser itself has a very low gas potential, as there are no organic binders which can burn. The burnt feed material does not get into the sand circle. This is because the material is calcinating during the combustion. The water class mixtures have a high pressure resistance. And of course, all these formulations are also available in fluorine-free formulations. I have to underline here this ASK is producing fluorine-free risers now for more than 20 years with a big success. Today, let's say 70 to 80% of our risers are already fluorine-free, completely fluorine-free. What gives some other advantages where I will come back later. We have no smell and no smoke pollution because of the inorganic formulation. And of course, ASK is not using any fiber materials to produce these risers. Not only the harmful ones, which we are not using, we use no fiber materials for our risers. In the cold box versions, we have some other advantages, and this is the first one is the high geometric accuracy. We have seen that water class bonded ones need to be dried in an oven, and during this drying we also have a shrinkage. The cold box ones have the final strength directly after curing, so no oven is needed, and that's why we have no shrinkage in this case, which gives this high geometric accuracy for these risers. The advantage is also because of this mixture of the exothermic and insulating ingredients like the microspheres, that they can also be used safely for high moduluses, means moduluses bigger than 5 centimeters, where are the natural limits of the inorganic ones. The burnt feed material usually detaches itself from the rest of the feeder. The background here is that once if the binder is burned, the granules itself are not hold anymore together, and these granules detach themselves from the feeder rest from the residual riser. With the microspheres, we can also have a high insulation effect, and also these organic formulations are available in completely fluorine-free formulations in ASK. So this lower density gives also that the aluminum contents is a little bit lower, and this can also have a positive influence on the metallurgy of the casted metal, because there is no aluminum which can influence the microstructure. And also these cold box bonded risers are do not have any fiber materials inside, same as we have heard already before. So as a summary, we can say the ASK risers are completely fiber-free. They are also available in fluorine-free, and they are available in organic and also in inorganic binder, which gives a much better footprint for the ecological behavior of these risers. So we have spoken already a little bit about the fluorine. Fluorine has some different effects on the casting quality. So the most important effect is that if you have a high fluorine content in the sand, in your molding sand, what happens quite often in green sand molding lines, that the fluorine from the riser is accumulated in the sand, and when you cast the metal, you can get a reaction between the liquid metal and the fluorine coming from the sand, and you have a kind of slag building, which creates then this surface effects, the surface defects, what you can see here on the left picture. The second picture shows the so-called fisheye defect, which is very often confused with the first one. This fisheye defect appears if there is exothermic if there are some exothermic crumbles which are in direct contact with the liquid metal, and if this exothermic crumbles have fluorine inside, then there is a possibility to create this fisheye defect. Another important point is the graphite degeneration. We made this experience here where we compared a riser with fluorine content and a riser from us without any fluorine, and we found in the microstructure, which is made directly in the riser neck in both cases, we have seen a big difference in the microstructure. So we found in risers with fluorine, we found some graphite degenerations, what you can see here. And in the same area, in the same section of the casting with a fluorine-free riser, you don't see any big graphite degenerations. Another important cost factor are the dumping costs. As much fluorine you have in your old sand and in your dust, the more expensive can it be to dump this material. This is depending on the depots. Each depot has different values and also different costs, but this is really an important point to save money in your in your dumping if your fluorine content of your old sand is lower. And during the last years, we made very often the experience that by using our fluorine-free formulations, it's possible to avoid or to reduce very remarkable the possibility of explosions and penetrations. We have had several customers where we switched from standard formulations from our competitors to our fluorine-free formulations, and we reduced the scrap and the rework remarkable. So in the next step, I would like to give you a product overview about our risers in a very short in some very short slices. We are producing, of course, all standard sizes of risers, some special sizes with introduced introduced neck reducing, yeah, or with metallic riser necks. About these advantages, I will talk a little bit later. And as you can see on the next slides, also important developments have been these modifications of existing risers, starting with modified insertable caps, and by the end also with neck down risers in cold box and in silicate, with a lot of big advantages. But the most sold riser in our production is today our Optima riser or our Optima riser family, which is the synergy from an already before existing two-part risers, our Click-Clack or KK riser, and the one-shot riser with the plastic lid. So at the time, we took the advantages of all these risers together and created the Optima family. This is the third generation of BKS or KMB QM. The riser itself is made in a one-shot production. We have low emissions from the plastic cover. We have a very clean Prager edge to the low friction pre-assembled metal tube together with the pin. By using different plastic lids, we can also create different volumes with the same riser. The application is very easy by using a rigid pin or a spring pin. Most of our customers today are using the maintenance-free rigid pins. Of course, as already mentioned, these risers also are available in completely fluorine-free formulations. And one important thing is that there are no casting defects coming from the riser material falling into the mold. What does this mean? Most of the risers have the roof made in exothermic material, and during the compression and the compaction of the molds, the molding sand, this roof can be destroyed. And these particles are falling then into the mold and onto the pattern, as you can see in the pictures on the right side. In this foundry, they lost a lot of time by cleaning the molds so that the cycle time was reduced. They switched then to our Optima risers, and there were no particles anymore in the mold, and the cycle time of the production increased and saved so a lot of money. Another important point is that so-called springback effect. So risers with metal riser necks sometimes are deformed, and when we have a deformation of metal, there are also the elastic and the plastic deformation. Here, if we want to have it, we want only to have the plastic deformation, but we have also the elastic ones, and this gives this kind of springback effect, which leads to cracks into the mold and can also create scrap and a lot of rework. As our metallic breaker core is without any pressure and frictionless inside the riser, there are no forces which are coming on this metal tube, and as there are no forces, there is no elastic deformation, and so we cannot have any mold cracks by using this riser family. So to show you some example of the riser application, I have prepared a short movie. In this movie, we show how our Optima family works during the molding and which are the advantages after the demolding then. We see now the pattern and how the riser is positioned on the pattern on a rigid pin in this case. So the mold is filled with sand and the sand is compacted, and you see then during the compaction the riser is sliding over the metal tube without any forces. So with this plastic lid also we can avoid that there are no crumbles inside the mold. So we have now the assembling of the mold. And we see now what happens during the pouring process. When the liquid iron arrives then at the riser, with this heat from the liquid iron, the riser starts burning and holds the liquid metal longer liquid inside the riser. This is up to 2 or 3 times longer than in non-exothermic solutions. We have all this data for the risers we have also available to use in simulation programs. When you can see here then the filling of the mold and also the solidification of the complete mold, and you see how the riser itself is working. So with these risers, we can improve the mechanical and structural properties of the casting, and this even much more cost efficient. So now you see the behavior during the demolding, and you will see in a few seconds that with this reduced neck area, it's much easier to fettle the casting means to knock off the residual riser rests. What you can see here now with this very small section, what we can achieve with this system. Yeah. And therefore, as this section is so small, it reduces remarkably the fettling costs. Improved yield, greater flexibility, and of course, we increase the structural and surface quality of the casting. So the important point for these risers is, as it is always when you have reduced necks, the right distance from the riser to the casting. And also for this case, we have prepared a short movie to explain this.
Achieve optimum casting results with the ExactCast Optima riser family from ASK Chemicals. This animation shows how it works and how it can be adjusted to produce perfect castings. To achieve the best results, the adjustment of the exact distance of riser to the casting surface is essential. If the distance between the casting and the riser is too large, the riser neck may freeze too early, resulting in shrink holes. If the distance is too small, there is again the danger of so-called fried egg defects or riser scabs. Therefore, it is important to determine the inner riser height from cover to outer edge before using the riser, and to measure this again on the molded riser from the cover to the riser neck. The difference between the two measurements results in the sand layer thickness between riser and casting. This should correspond to the specifications in the reference table, depending on the riser neck diameter. If the distance is too large, the correct distance can be achieved by shortening the standard riser pins. A too small distance can be corrected by using risers with special reinforced covers. Correctly adjusted riser distances guarantee the perfect functioning of ExactCast Optima risers. ASK Chemicals. We advance your casting.
So now you see again the position of the Optima risers before and after compaction. And with this riser, we did not stop the developments. We have also improved these risers step by step to respond on the needs of our customers in the foundries. So the first approach was to have this riser also available for foundries who are using hydraulic wedges to remove the residual risers. In some cases, that was not possible as there was no counterface to position the wedge. So for this, we have developed a new geometry of the Optima risers with ribs inside. And with these ribs, then it's much easier possible to position this hydraulic wedge to remove the residual risers. In a further step, we have seen that sometimes the metal tube is falling back into the mold, and that's why we have created a variation of the tube with a metallic lip around. And with this metallic lip, we have also much better results that the lip cannot fall back into the riser if the sand compaction is not perfect. So that can also compensate some bad compactions of the molding sand under the riser. And also this geometry has the advantage that it makes the neck much stronger here. And in some cases, this is also useful if you have forces coming from the side, and this has sometimes an influence of the metal, that these forces can create an oval neck by deforming the metal tube. And then with the lip, we have a much higher resistance against these deformations. What we also have seen sometimes on very high and exposed flange geometries, that the molding sand is flowing away and the riser is crushed onto the pattern and comes too deep. So in a good case, the distance is not enough, and in some bad cases the riser can be destroyed, like you can see here on the image, because the riser is going too much down during the compactions. So it means the riser distance is too small. For this, we have developed this reinforced lids, which holds the riser in the right position, as you have already seen in the short movie before. So that's why we have developed this Optima 2.0 as a modular riser with a wide range of customer-orientated variation options. So the Optima is a riser family for all applications on the molding lines, means screens and molding lines in this case. We have also developed an exothermic lid instead of the plastic lid. In this exothermic lid, we have a plastic tube, a very small one, to avoid the crumpling, what we have seen before in some cases. Yeah. We have also here the effectiveness of a closed riser, and with the all-round Williams bar in the neck, in the roof of the riser, in the lid, we can produce or we can achieve the same module with a smaller riser geometry. Another point is that we have also developed exothermic tubes instead of metal tubes. This prevents the freezing of the riser neck a little bit better, and we have more flexibility for the distance from riser to casting to have a really good working riser. So this shows the summary of all the possibilities what we have. We can work with different sizes of lids, what gives different volumes. We can use the standard plastic lids, the reinforced lids, metal lids, and also exothermic lids. And we have the different tubes, the standard tube with pearls, the tube with lips, and also the exothermic tubes. And here you can see the overview what it means with all these different positions. So that means that the Optima riser for your application, thanks to a free choice of formulations and individual components, can be the perfect solution in your foundry. So as summary, we can say we achieve less volume. We can achieve reduced cycle times with these risers. With the less volume, we have also less pouring time. We achieve higher yield. We realize smaller fettling areas. With this, less segregations and hot spots under the riser. All these risers are, as already mentioned, available in completely fluorine-free formulations, what gives better metal quality. With the smaller metal volumes, also faster remelts, what leads to remarkable savings in process costs and leads to our customers to much more competitiveness by using our risers. Thank you very much for your attention, and now please ask your questions.
Thank you, Stefan. Thank you for the presentation. It was very interesting, and I already have a question, but I would also like to invite everyone who has a question or maybe a comment, just type it in the chat function on your right-hand side. So the first question is, what is the influence of the plastic lid on the gas development during casting?
This is a good question, Isabel. This influence is very low. I will explain you why. We have developed here, or chosen, let's say, we have not developed it by our own. We have chosen a plastic which burns more or less like a candle, yeah, and it has a really good combustion. And of course, it is an inorganic part which is which has a little bit gas development. But if you compare an inorganic riser with this organic lid and compare this with a completely organic riser, the gas development, it's really very low. Let's do a simple calculation, as you know, perhaps, because of the smaller granularity of the ingredients from a riser, you need up to 10% of binder to have this riser in the needed strengths and so on. So that means that an organic riser has, without plastic, already more or less 100 grams of organic material which is burning. If you choose the KL riser with inorganic formulation and the plastic lid, you have only the plastic lid, which gives around 10 to 12 grams only in organic material which is burning. So compared to the organic riser, very big difference, and much less gas development coming from this plastic lid.
Thank you, Stefan. Yeah, and we have another question. Let me read it to you. Which influence has the climate to the silicate bonded risers in terms of humidity?
This can be a big influence, of course. So inorganic risers, the silicate binder is hygroscopic. And if you have a climate in your country which is which has a lot of humidity, we have two possibilities. The one possibility is that we have some special packagings, that we have each carton tray packed with wrapped with shrink foil so that the risers are protected. And another possibility is, of course, to produce these optimizers also in cold box formulations, which are much less sensible for this humidity coming from the climate.
Okay, great. So far, I don't see any further questions, any comments. You're still welcome to place it in the chat function. Yeah, once yeah, we can see it, and of course we will get back to you. Also, if you have questions afterwards, you can of course contact us. You will find our contact information on our website, so please feel free to go onto our website for our contact details. So Stefan, I really hope everybody enjoyed today's webinar. We are at the end, and I hope that we might welcome everyone in our next Casting Academy. As I said, on our website, you can find our contact information, but of course, you find more. You will find our digital services. We have the ASK product finder of each product line where you can see with special characteristics and attributes our products that we might offer. You can contact us over there. If you have a specific question to one of our experts, please feel free to go to the website and ask your question, and I will ask the expert. You also find there maybe already your answer. We have a little Q&A to where you can read already some expert knowledge. Of course, all our expert knowledge we have summarized in white paper and technical paper. And of course, as you know already, we have live and also on-demand webinars. Feel free to have a look around, and we are we would be happy if we could welcome you to our next live webinar in a couple of weeks. And also, if you want to see an on-demand one, just register. For now, thank you again, Stefan, and I wish you all a nice, great rest of your day or start of your day, depending on where you are. I look forward to your evaluation of the webinar directly after this one. You can just stay in. We will close the webinar now, and you can just click a button. So thanks again, and I hope to see or hear you soon.
Thank you also from my side, and thank you, Isabel, for your moderation. Have a nice day. Bye-bye.
Bye.